So this talk changed a little bit if you ever read the original abstract that I posted like 6 months ago. It just so happened that we got a lot of work done this summer. As a result of that, pretty much all the technologies I listed on the original abstract were no longer relevant. We replaced them and did a whole lot of other work associated with a co-location move. So there was a last minute change to the abstract. It should have been up on the actual online schedule, but yeah, the original one was a bit different. So there's a collection of tools and mostly a handful of challenges that we've overcome over the last couple of years managing our virtual environments. So, like Terry said, I'm from Puppet Labs. I've been there for just over 4 years. I was not the first operations engineer. That is a title given to one of my workmates. But I'm the current systems team lead, so I lead a sub-team of operations, and I'll go over kind of a little bit of the structure and philosophy of how operations works at Puppet Labs before we move too far. So we have a core operations team. That operations team is kind of split up into 3 sub-teams, and we basically provide the rest of the company and other departments core services to build other applications on. This is a symbiotic relationship in that we also then use those applications that the other parts of the company then put on top of our infrastructure. These are predominantly focused-based teams, so they're not necessarily silos. I have access to every system administratively and generally understand how they work across the entire operations team. And we found that it's actually also largely important for me and me primarily and my team to understand what some of the other infrastructure management and departments at Puppet Labs are also doing, because they ingest my team's services so heavily. So yeah, we do everything from core networking out to application services, but I specifically maintain virtualization and cloud platforms, storage, and our backup services. We also have a business operations group, which does business intelligence, engineering services, which maintains all of our CI pipeline and release engineering. And then there's also a corporate IT team, which is really actually just kind of part of the core operations team, and they work right next to us. I'm pretty bullish about this one. There's no DevOps teams at Puppet Labs. There is no one with a DevOps title. I know there's tons and tons of research lately. Gene Kim talking about it yesterday. We've done a DevOps survey the last couple of years, and it's all very obvious that as far as the industry is concerned, departments with the word DevOps in them get more stuff done, and people with DevOps titles get paid more. But at Puppet Labs, if we were going to name things DevOps, every department would be called DevOps. We all have to do DevOps, and this is the thing that about kind of the definition of DevOps that always kind of gets at me when people start talking about it as an entity, as a job title. One of the core components of DevOps is cross-functional communication and teamwork, which that is obviously not necessarily something that happens inside a single team. By virtue of cross-functional, it's supposed to be cross-teams. So we all do it every day, and I interact with every other team inside Puppet Labs many times every week. So we have the team has been built organically and has had to keep up with a very fast pace of growth. So we didn't all come from the same industry. The whole team didn't all come from like a large-scale web ops team. We didn't all come over as storage admins from some EMC VMware shop. We all have a very diverse work skill set, and this has turned us into being a very agnostic infrastructure organization. So when you're agnostic, you end up picking a lot of tools. So we end up becoming fairly heterogeneous. And this is where the challenge comes with managing our virtual environment. So this first list is all the traditional virtualization platforms we currently maintain at Puppet Labs. The top 6 are actively in production. That 7th one was a request right before PuppetConf last week so that we can do more product validation on Spark platforms for developers. And then the last 3, I don't necessarily have to maintain those virtualization platforms, but our IT team has to be very aware of them because those are all the platforms that people use to work remotely from their laptop when they don't have access to shared virtualization infrastructure. So yep, we use all 3 of those on the bottom. People pretty much get to pick what they want. So this list continues. In total, we have 14 virtualization platforms if you count cloud providers. So there is active production customer-facing infrastructure on every one of those right now. GCE holds the Forge. EC2 holds some testing and S3 for the Forge. And we have Jira on Linode and PuppetLabs.com on Rackspace. I'm going to save you the other lists I could have made because this continues. This is a trend. We have multiple hardware vendors for compute platform. We have multiple storage vendors, networking vendors. Luckily, I think it's only 3 networking vendors. But I didn't want to go into the data center and actually count every different type of super micro vendor I have or every other kind of big name vendor either. So it keeps going on and on. So why did we end up with such a long list? Well, I mean, being agnostic, I said it has something to do with it. But there's a large set of necessity there. So Puppet Labs is a little special in the way that we have to build infrastructure because we write software to maintain everyone's infrastructure. We're not just a cloud company. We're not just a networking company. We're not just a data center software company. We build a platform that everyone can use across the industry. So we have to be familiar with all these types of pieces of infrastructure. You can't just say we're only going to test in a cloud environment and then expect everyone to be able to deploy this stuff to a Spark cluster or a VMware environment. So all this stuff is, it actively sits inside a CI pipeline automation. And so they are ingesting that much like a cloud provider. And so operations responsibility is to understand, basically be the job of EC2, be the job of Amazon in the case of AWS, and maintain and make sure all those hypervisors are functioning. The kind of best tool for the job and not picking large complicated systems to solve simple problems. So this comes out of when we need to ship, let's say, infrastructure in a box to a remote office. So we're bootstrapping a new office. They need fairly static day-to-day components that allow them to gain access to their work. So we're not going to ship over a whole VMware cluster. No one needs the advanced features of OpenStack's layered networks or the ability to export multiple block devices. They just need a hypervisor. So we have a very simple libvirt KVM hypervisor installation. It uses one Puppet module written by Carlos Souza many, many years ago. It was the first thing I reviewed when I joined Puppet Labs. It's simple, installs like 3 packages, and we move on. You can also manage the VMs with that platform. So generally, our VMware and OpenStack environments only live in the data center. So it's whenever someone needs to actually do a lot of work. So the CI pipeline, obviously, it probably does a lot of work. And we'll look at the graphs here in a little bit. But that's, of course, that's been deployed on VMware. We made that decision many years ago. And it's so that we have a certain level of ability to maintain a cluster of VMs and move them around and have a single point of provisioning. And of course, in the end, we moved fast, and yeah, there was some lack of follow-through. Some of the cloud providers were supposed to be abandoned. Every time we decided to abandon a cloud provider, we actually multiplied cloud providers. We've never fully abandoned a cloud provider. We're working on it. So the challenges that we have and that we've been trying to solve, you may be, I don't know, a little surprised that I didn't put orchestration up there. Orchestration really isn't one of our problems right now. From kind of a hypervisor deployment perspective, deploying a static hypervisor environment is very straightforward. There's some orchestration tasks that we're looking at doing, and right now we're looking at high performance, kind of low-level SSH type orchestration. So there's some experiments going on that we're trying to work through. Nothing complicated at this time. It's not a multi-tiered, very complicated web app that we're trying to actually, maintain here. So what it comes down to is it's actually a lack of insight and automatable APIs. They're the big ones. Everyone has a monitoring problem. That one we're still actually working through, and we're actively working on the debt problem as well. But the other two we've made a lot of progress on in the last couple of years, or the last year actually mostly. So this isn't all automated. All of our stuff is not. And we do have a problem with data normalization. These platforms, even though we have worked on getting their data out into a common platform, the data sources have kind of different interpretations, different actual, the data comes with a different decimal point, or it comes as a percentage or a millisecond, which is different than another platform. So things not being all automated, we've fallen into a trap a couple of times. We've decided to no longer support a platform, we've deprecated it. And so everyone goes, well, I don't want to write automation for something we're replacing. And so you start working on a new platform. Well, that platform stalls, or for some reason, we need to ramp up the amount of platforms that Puppet Enterprise supports. So all of a sudden, that old platform that we said we had deprecated, which is actually the only platform we have, we've all of a sudden bought more resources and are trying to set them up again. Well, we canned that whole automation idea. So now we're doing it by hand again. So we've stopped that as well. Now we just do the automation. If the thing's not actively being torn down, it's being used and it has a potential of expanding. And if it is that the automation is built and we never expand the environment to use that automation, we've still learned the workflows, put a framework in place. All we need to do is flip some code out of the back end and we can probably use it on just about anything else. So there's no loss there. We might as well spend the time to do the work, because in the future we'll be able to use that automation and gain our time back. If anything, it's an educational exercise. And anything that makes my team better at understanding how to do automation across the platform is a good thing. So the number one thing we did to obtain insight across our platform so that it was actually manageable was eliminating dashboards. So eliminating sources of truth. Pulling it all into something that we can actually query and do correlation across. So this is what we used to deal with. This is a VMware snapshot of the vCenter console. If you can see that, I don't know how visible it is out there for you guys, but the chart basically says only real-time data available. So I can't do anything historic. Then the next one we fought with was this thing is unreadable and hard to navigate through. There's no way to actually change the queries or narrow them down. And we'll also notice down at the bottom it says loading. when I took this snapshot, I let it sit there for about 5 and 10 minutes, and it never loaded. So if I can't get my data now, when there's a problem, and I'm trying to troubleshoot things, then I consider I don't have data. Third example of this not working, this one also timed out. So no data whatsoever. So we replaced this with graphite and ended up with this dashboard for basically the thing that replaces this. And so we've defined our own queries. We can build them out in a parameterized fashion and actually get data. And so this also means that I can get historical data as well. So we pull all the real-time data into the system and then just keep it forever. It's also split the sources of where we get data. So in the vCenter context, all the place where data and statistics lives is in the same place that that stores the virtual machine metadata. So if we want to get a query out of vCenter and launch some virtual machines at the same time, the database starts thrashing, and you can't get metrics or launch virtual machines. So we've separated that. We were able to start graphing statistics that did not exist in the standard platforms. This one is a graph of vCPU versus core ratios. This was something we were never able to capture inside standard VMware consoles. And so we just started writing extensions that started querying the VMware API and started doing our own calculations. So you can get this functionality by purchasing other things, but we really didn't want to. And so through a couple of API calls, something like 20 or 30 lines of Ruby, we were able to calculate this. We weren't calculating it before. This is why this was such an advantage for us to start calculating it. The day I started calculating it, I found out that we had a 25 to 1 vCPU to physical CPU ratio. We started troubleshooting why things were lacking in performance. And we found that really, really high testing cycles would put VMs into a state where they were waiting for CPU cycles nearly 80% of the time that they were doing work. So we were totally over-provisioned. And now we were able to graph that. We identified it. We bought more hardware, and it's down to 5. I think that graph actually says 6. It bounced up right before I took the snapshot, but it's constantly, normally at 5. Our plan is to stay around 10. So now that everything is inside a Grafana or Kibana-based dashboard, I can sit all of my VMware information right alongside EC2 information. So this is using the AWS CloudTrail, and there's a CloudTrail codec directly into Logstash. And so we're just pulling every API call that happens in AWS. And we track that to understand, are people leaving machines up too long? Do we have applications that aren't killing things appropriately? So we can track, this is only showing AWS's EC2 instances, but this does every other API call. We're just in this dashboard caring about instances. And I can do this across, I can separate this all by user. This is actually one of the, you have 2 ways to track who launched a virtual machine in EC2. You can rely on them tagging it, or you can cross-reference who owned the API call when they made it. So this has all that data in it, so we could actually figure out who owns a VM in the event that it needs to be taken down because it's been exploited. Now, we're able to start getting dashboards like this as well. And this one is built by our ESR org, which tracks all of the successes and failures and time it took to run a test during the day, or 24 hours a day. And so what I can do now is, alongside all these dashboards, I can see the correlation between a host's CPU utilization and the performance degradation that it's causing on our testing system. We can actually follow those spikes along each other. And this is previously to deploying this stack of software, that was totally impossible. And so, like I said, we pretty much just over-provisioned a large section of hardware and kind of scratched our heads when it fell over. So these are all of the things that we actually deploy in order to get all these statistics. Everyone's probably heard of most of these. The one on here that was kind of a surprise find, we found it on a random VMware website. It was their labs website. It's a Fling, the stats feeder one. It queries vCenter for all the statistics that it's generating, and we can output it as CSV, and we import it into Graphite. That kind of saved our bacon. We wouldn't have been able to get any of this data without that. It's a free piece of software, but they don't necessarily update it, so I'm kind of freaked out that it'll stop working someday. All the Puppet modules to get going, those are about half Puppet Labs modules and half, well, only this top two are Puppet Labs modules. And then the Elasticsearch and Logstash ones actually come directly from Elasticsearch. And then Gareth Rushgrove, which is, we're deploying Diamond to get all of our OS level statistics. Wrote that module before he was a member of our company, but he now works for Puppet Labs as well. So the results of this work was we removed VMware dashboards, EMC dashboards, Jenkins dashboards, and Amazon dashboards, and put them all in one place. We identified new metrics that we could process and presented the presented metrics for the first time. So the next hurdle that we've had in managing our environments are APIs. Everything today says it may have an API. Being called an API is not enough. I came up with this phrase. I was doing a talk on comparing VMware APIs to OpenStack APIs from a kind of a Ruby library point of view. No surprise, the OpenStack code was anywhere from 50 to 25% the length of the VMware stuff. And so we take these into account when we make decisions on platforms now. Are people going to actually be able to use the API on a day-to-day basis without learning a large set of new concepts? They got to be able to jump in with the platforms that they are familiar with already. Okay. So we ended up so far with, these are two examples of applications that have been written to basically replace the interface that VMware gives us because we could not get people to use it. And so that was a hurdle for us to actually manage our environment. So if someone goes, well, I need to spin up a whole bunch of virtual machines, try something on them, and then delete them because I don't need them anymore. If you tell them they have to go through the workflow of cloning every one of them, doing it from the web console, or they have to boot up a Windows VM, and then they need to load all the OS, and they need to go through that step every time. What they end up doing is they just turn VMs on and never turn them off, and never clean up. You would be lucky if they tag them with like their name. And so these VMs live so long that eventually VMware expunges the history of the tasks that were executed on it, which results in us no longer understanding what's going on. So we just created a couple tools to wrap all that stuff around, which has made it very successful, actually. Let's go. Are we going to get there? Yeah. Okay. So this one's very simple, very quick. It is a single file Sinatra app. It took me a couple hours to write. It's less than 200 lines of code. I think it's like 175 or something. And the whole idea is to just take a subset of the things that we already knew what VMware did, and just to make it look more RESTful. Because the standard vSphere API is SOAP, and it takes a lot of work for someone to understand how to interact with that API. And most of the documentation for the API was in Java as well, and the operations team isn't a big Java shop. So this was really quick. It took me, like I said, took me nearly no time at all, and we're already deploying virtual machines with it. I've given it kind of a OpenStack EC2 flavor to it, just so that it's a bit quicker to actually, for people to pick it up if they're already familiar with the EC2 environment. Like I said, very simple. For the most part, I've hard-coded a lot of stuff into it right now. It's not very configurable, but yeah, it's pretty small. So the other one is that we have internally is a little bit more robust, and this one was written by Scott Schneider, one of the team members in ESO. And so we ended up having a problem getting virtual machines to clone fast enough in large enough quantities to run our testing matrix. So he wrote a machine that basically application that basically manages a pool of virtual machines, so that we have 20 Debian machines, 20 CentOS machines, and what people do is they request them out of the pool. We run a test, they can do work on it, or our Jenkins can request 15 of them, set up a master and many agents across many different platforms, and run all of our acceptance tests. Then we just hand the VMs back and they get destroyed. All the while in the background, the pooler is replenishing these virtual machines for us. And so they're always instantly on demand. Tests don't wait for things to clone anymore. Stuff to do work is always available. That's configuration. So API is very straightforward. You do a get for a virtual machine on a specific endpoint based on the template, and it'll return you a set of JSON of what are basically the host names of the virtual machines, and you log into them. So the only reason that we also wrote the other one was this is supposed to be very dynamic. Sometimes operations has a need for static infrastructure. And this is actually, by default, kills virtual machines after 12 hours because we want them always to be fresh and pristine to actually run tests on. So these also have hardly anything installed on them. For a while, and this still actually happens occasionally, but our developers loved this workflow so much that they started running tests from their laptops and depleting the pools faster than we had calculated they would be depleted. Because there's no authentication across this system in this case. So we go, here's the rate at which we run tests using Jenkins. So this is how big we need the pools for. And then all of a sudden, the pools will just disappear. So the interface has been very successful. Where is it at? There you go. Okay. So it's kind of, I always think, what can you do in just a couple hundred lines of code? What piece of your day-to-day life and the frustration can you get rid of by just sitting down on the couch one evening or in the morning? I mean, who doesn't work remotely, I suppose? And just find something and write a little Sinatra app that does something, or a script. That's a drive inside operations, is just you don't need to solve the whole solution to make something more manageable. Little snippets, a couple of lines of code, that's all you need. Yeah, so getting rid of all that debt. Because we have this, we can only kind of now start doing this. Now that we've identified how we're going to manage our environments, and the tools that we must have in place for those environments to be maintainable, we can now start looking at all that past debt and go, does that tool actually fit our new desired feature set for actually interacting and understanding what's going on? So we did our first cloud evaluation like 4 months ago. And this was just a quick example of the matrix that we built. It was very straightforward. It was pretty much weighted all the way towards things that had an ability to export metrics. So I don't necessarily care, I suppose, if a platform has its own dashboard, its own understanding of some metrics. Maybe it has a unique way to express those metrics. Some of the Puppet-based dashboards may look at the way that events and resources are handled a bit differently than kind of your standard tool like Elasticsearch and Logstash. But in order for me to do correlation and for me to understand what's going on across my environment, I at least need to be able to have my first pane of glass, my first source of truth to be all the same tool. And I can't have it be a vendor's tool because you don't understand my business logic. And so it's been very successful using open source software that we can basically munge to understand and absorb our data. It all has become, can we programmatically access data and get it into a form that makes it ingestible by the rest of the company? So this is also happening from our, not just from the compute point of view, but on our storage platform as well. So I went through a day of reverse engineering a SAN that we had that had its own reporting tool. And I eventually found that you could export a CSV. Well, there was no way to do it through a terminal or through a script. And so I launched some Firebug and traced every call and replayed that inside a Ruby script. And lo and behold, I was able to download this CSV. Well, we looked at that and we went, what if we just installed Diamond on it? Well, we can't install Diamond on this SAN, so we ended up replacing all of our SANs with traditional Unix boxes and used ZFS and then put Diamond on them, and we're in the process of writing ZFS and NFS data collectors for that platform in order to get all of our metrics. And so when we move to a distributed platform, and it's very likely that distributed storage platform may just likely be Ceph because Diamond already has all those collectors. So when we start evaluating all these platforms that are available, we can look at it and we go, this is what's going to give us the insight into the platform. There may be an argument about, well, this one's technically superior and this one scales better, but we can look at it and go, well, how do we know to scale it if we don't have metrics out of it? And so we may end up having to put more effort into scaling, but at least we actually know when to scale things. That's always kind of been our major problem. So now we're kind of at the standardize and optimize part of the whole process. And just kind of paring back all of those tools. We're down to a single Supermicro vendor, a single blade chassis vendor, and a single set of operating systems for the most part. But the hypervisor thing is never going to go away. We're always going to have multiples of those. It's just, and networking providers as well. We need Arista, Cumulus, Cisco, and Juniper, all those platforms just to actually develop software. Okay, well, I have 5 minutes left, so if anyone has any questions about the challenges it took to actually get there, I mean, some of it honestly was organizational, but there was a decent amount of technical work that went into just understanding what the metrics were. So thank you.